Well, hello again, classmates of MECH 1310 at Chattanooga State Community College. Today, what we're going to introduce ourselves to will be resistances or resistors connected in series and resistors connected in parallel. So, let me get a clean board here. And the first thing that I will draw will be a series circuit. Okay, a circuit is an arrangement of a conductor and a power source, or a source of electrons that allow the electrons to travel from one side of the power source or the battery to the opposite pole on the same battery. So I think we can recognize our symbols here now. A battery, one resistor, two resistors, three resistors, and back to the positive pole of the battery. So we're looking at our single cell battery here, and by now we know that the short side or the short plate is a negative polarity and that the long plate is the positive polarity. So current will travel as I always do it. Remember that just because I do it that way doesn't mean the world is that way. And what I have is I have my current traveling in a clockwise direction in this circuit. And we'll call this resistor 1, resistor 2, and resistor 3. Now then, we know we've been introduced to Ohm's law, so we can talk about that also. But let's talk about how we use Ohm's law here just a little bit, and how it applies to the resistances shown in this circuit. So the current flowing in this circuit will be equal to the voltage of the battery, and it will be divided by the total resistance of the circuit. Now then, since this is a series circuit, okay, the current has no choice. It has to travel through each of these resistors. It has no alternative path, okay? And that's why we call it a series circuit. In this case, and in all cases of series circuits, our total is going to be equal to resistance 1 plus resistance 2 plus resistance 3. Okay. There it is. So let's give ourselves some values and that we can try this out. Let's say that resistance 1 is 10 ohms. Resistance 2, which I just smudged, is 20 ohms. And resistance 3 is 30 ohms. Let me see if I can correct my smudging here. So I have 3 resistors, one equaling 10 ohms, one is 20 ohms, one is 30 ohms. So our total, coming back to my red marker, is going to be equal to 10 ohms plus 20 ohms plus 30 ohms, and our total will be 60 ohms. Let's give our power supply, or our battery, a voltage, and let's make it 30 volts, and it has to be DC because it's a battery. 30 volts DC. So if I come back to Ohm's law, which is equal to the voltage of the battery divided by the total resistance in the circuit, what we can see is that the current flowing in this particular circuit is equal to the voltage, which is 30 volts, divided by the resistance, which is 60 ohms, and that will be 0.5 amperes. So that is our introduction to series resistance, a series circuit. We had a battery of 30 volts, resistances of 10 ohms, 20 ohms, 30 ohms. Total resistance, because it is a series circuit, okay, total resistance equal to 60 ohms. Current flowing in the circuit is equal to the voltage of the battery divided by the total resistance, 60 ohms. So 30 divided by 60 is equal to 1/2, or 0.5 amperes. So current flowing in our series circuit is equal to 0.5 amps.